Hello everyone, and welcome to part 3 of how to build a drone. So in parts 1 and 2 we covered frames, we covered motors, and we also covered electronic speed controllers. And in this video I wanted to talk about flight controllers. So let's go ahead and start with some historical background. So flight controllers are usually named as F1, F3, F4, F7. I'm sure that you must have heard of those names, But what does that mean? What does the F and then the numerical number after it mean? So it basically refers to the microcontroller unit mounted on this board, which is the flight controller. What is the microcontroller unit and what does it do? It's basically a processing unit that sits on top of the microcontroller and provides processing functionality for the quadcopter. An F1 controller versus an F7 or an F3 or an F4, they basically differ in processing speed. They differ in the number of ports that they are capable of supporting, and they also differ in the size of the flash memory that comes on board. So to give you an example, the earliest version, which is basically the F1, had a microcontroller unit that was capable of a 72 megahertz clock speed. It was also capable of 2 UARTs or 2 ports, and it had a flash memory of 128K. And F3, in contrast, still had the same processor speed, but it supported more UARTs or more ports. So it supported 3 ports and came with a bigger flash memory, which is 256K. And F4 had a tremendous jump in speed. So we jumped from 72 megahertz up to 168 megahertz, but it supported the same number of ports or UARTs, which is 3. It came with a substantially bigger flash memory of 1 megabyte. For the F7, we've moved to a little bit higher speed of around 216 megahertz, but we've substantially increased the number of ports for the microcontroller unit, which is 8, and it came with 1 megabyte of flash memory. So why is it that we need more and more processing speed? Why do you need more ports or UARTs? Why do we need bigger sizes of flash memory? So basically, the memory is used to house the flight controller firmware. So as we move in time, as the firmware basically becomes more and more advanced, we will need bigger memory chips so that they can house the bigger sized firmware. That is why the flash memory has been increasing in size. Same thing for the processing speed. So as the firmware becomes more and more advanced, we will need more processing speed to support this more complicated firmware. And in terms of the UARTs or the ports, a port is basically a point where you can connect an external device to your flight controller. So for example, you might connect to a UART, you might connect a receiver or a GPS unit or a speed sensor, or basically a proximity sensor, or any other sensor that you can think of. So basically, the more UARTs you have or the more ports you have, the more sensors you can connect to your flight controller. So let's basically move to another topic regarding flight controllers. So you must have heard a lot about the gyro sampling rate and the FC loop time. The higher the processing speed, the higher the flight controller is capable to support higher sampling rates for the gyro and the flight controller loop time. But what do they mean? So a gyro sampling rate is basically the rate at which the gyro samples or the gyro sensor samples data. And then the flight controller loop time is basically how often we take that data collected by the gyro and run it through the Pid Loop. The PID loop is a different topic by itself, and it's a lengthy topic. We can talk about it later. But if I want to put it in a very simple way, the PID loop or the PID loop is part of the flight controller software. It basically reads gyro sensor data and determines how fast motors should spin to achieve a desired rotation speed. So it basically, determines how this aircraft or how the drone flies. And the PIDs, if you go into beta flight, for example, it's a set of parameters that you have to change or set to tune your quadcopter. And the better the quadcopter is tuned, the more locked it feels, the better it flies. Let me go ahead and connect this flight controller to the drone. So as you can see, in the last videos, we've mounted the motor, and we've soldered the motor to the ESC, and we've soldered the main battery lead here. And as I mentioned last time, each ESC basically has a set of cables that you need to connect to the flight controller. The reason is we want to send data from the ESC to the flight controller and vice versa. Data like, the motor, the motor signal, telemetry data, power source or voltage. So in my case, this ESC is compatible with the flight controller. They are both manufactured by the same company. So I'm using this cable which came with the flight controller, and you don't have to swap any wires. What I have to do is just simply connect this cable to the ESC and simply connect it to the flight controller like this, and then mount the flight controller on top just like this. What remains to make sure that all the signals are correctly read and interpreted correctly by the flight controller and the ESC is that I go into the software, which is Betaflight, and configure each port for the data that's being used on it. Okay, so I wanted to go through the pinout diagram for the flight controller I've shown you earlier. This would enable you to understand what each and every pin is used for. So let's start with this series of basically pads on the left hand side, and we'll start with the top pads. B plus is basically battery voltage or battery positive voltage. And you can connect up to a 6S battery directly to this flight controller at this B plus pad. That voltage will basically power it up and enable you to basically enable the flight controller to sense the voltage level and report that in the OSD or the on-screen display on your goggles. The 5V or 5 volt pad here is simply a power source. So after the flight controller takes that B plus voltage, it has a step down power supply that can generate a 5 volt filtered power that you can use, for example, to power your camera or any other peripheral that needs 5 volts. V out and V in. So V in is basically the video signal coming from the camera, the FPV camera. So you connect that cable here to the VN, and then this signal would basically be processed by the flight controller, and it will put OSD data on that signal, and then you can take the output signal through V out, VO, which is basically exactly the video signal coming from the camera, but with the OSD data overlaid on it. And then you have below that 2 ground pads. So for example, if you're connecting a 6S battery, you would connect the positive terminal to the B plus and the negative to the ground. If you're powering a camera through the 5 volt pad, you would connect 5V to the camera and ground to the camera ground also. Okay, IDET or IDET is the current sensor. And we go back basically to what I've explained in the previous video regarding electronic speed controls or ESCs. So some ESCs have a current sensor, and there's a cable coming out from the ESC labeled as I or current sensor. You connect that here at IDET, and then the flight controller will be able to basically understand how much current is the ESC is going through the ESC, and then you can basically overlay that on your OSD. RSI, that is basically used to basically overlay the RSSI data or the received signal strength indicator for the receiver on the OSD. Some receivers have like a pad that you can basically solder a wire to, and then solder that wire to the RSSI pad, and then the flight controller would know what the received signal strength indicator is, and you can display that on your OSD. And then below that, you have what we call R66, R44, R3T3. Those are the UARTs, or basically the ports we spoke about earlier. Those are the ports that you can use to connect external sensors like a GPS sensor, or basically, a speed sensor, or even a receiver. Then we go down. Again, we have a 5-volt pad, a ground, and we have a 3.3 volt pad. This 3.3 volt pad is used to power up some receivers that take only up to 3.3 volts. The last pin is called SP, or smart. I mean, in this array of pads, the last one is called basically SP, or smart port, and this is FrSky specific. Smart port is an FrSky port that was developed that can be used to basically transmit telemetry data. So basically you can connect or wire your FrSky smart port to this pad here on the flight controller. And then we go down. You have pins like, ground, and then LED. So you also can connect an LED peripheral device to your flight controller using the LED pad. You have another 5-volt pad for a power supply, 5-volt power supply. You have a buzzer pad. So if you have a buzzer, you can connect it here. Buzzer minus means the buzzer has two leads, a plus and a minus lead. The plus goes to the 5-volt, and the minus goes to the buzzer minus port. And then you have M4, M3, M2, and M1 ports. Those ports are basically the motor ports. Again, remember, we have 4 wires coming out from the 4-in-1 ESC labeled as M1 up to M4, which are the motor 1 to motor 4 signals. And you have to connect them here to M4, M3, M2, and M1 over here. And this is basically the signal that the flight controller transmits to the ESC to tell it at what speed should each and every motor spin. I want to also talk about this 8-pin connector, which would basically help you in the sense that you don't have to solder all of these cables. It has a set of pins in this 8-pin connector, which basically directly connects signals from the ESC to the flight controller. So let's see what those signals are. I'm going to scroll down, and this is the 8-pin connector with the pin-out diagram for this connector. So pin number 1 here on top is the battery voltage. So you don't really need to solder B+ to this pad. You can simply connect the 8-pin connector here, and pin 1 will be the battery voltage as relayed by the speed controller. Pin 2 is R5, or basically the receive port for UART5. So every UART or every port has 2 pins. So for example, R6 and T6. So this is port number 6. R6 is the receive port, and T6 is the transmit port. So if you go to the 8-pin connector, pin number 2 is R5, which means it's the receive port for port number 5, or the it's the receive pin for port number 5. And this is typically used for ESC telemetry. So we basically take the telemetry cable from the ESC, and then we connect it here to port number 2. And this is done automatically because, as I said, the ESC that I've used in this example and the flight controller are compatible. So you don't have to swap any cables. It's gonna by default connect the R5, which is basically ESC telemetry, to the telemetry cable from the ESC. But if you're using an ESC and a flight controller that are not compatible, you will have to swap the cables to make sure that you connect the right cable to the right pin. Going to pin number 3, it's basically ground. Pin number 4 is the current sensor input. So remember we spoke about IDET pad, where you can basically solder the current sensor cable. You don't need to do that if you have, you can basically connect this 8-pin cable and you will have the current sensor input connected directly to pin number 4. And then the last 4 pins are M1, M2, M3, and M4, which are basically the motor signals that transmit the motor speed motor speed signal from the flight controller to the ESC. So this is basically in a nutshell what the pin out diagram is and what each pin does. I hope you benefited from this video and it gave you a quick and good overview of the flight controller and what it does and the different pins. Of course, this is one example. You have so many types of flight controllers with different pin out diagrams, with different functionalities. But the hope here was basically to give you an overview or a quick idea about the flight controller and what kind of pins it might have, which would put you on the right path to be able to read pin out diagrams and determine what each pin does. If you believe that this information has benefited you, please click on like and subscribe. That would help a lot. Thank you very much for watching and have a nice day. If you have any questions, any comments, please don't hesitate to post them in the comments section and I'll be glad to basically answer all of those. Thank you very much again and have a nice day.